Since we are now busy with circles in analytical geometry, we unfortunately cannot escape what we already know about circles and all of those properties and theorems and whatnot that we did in Euclidean geometry. So, of course, those are still relevant, and specifically, one that we're going to look at today is going to be the role that tangents can play in the questions that they give you. Okay, a tangent, of course, is a straight line, and they can ask you questions about the relationship between a radius and a tangent, right? That's one of our 3 tangent rules that we have, or theorems that we have. And why they can ask you about that is because we know they're perpendicular, right? So the gradient of the radius and the gradient of the tangent, when you multiply them, it's going to give you -1. So that's something you need to keep in mind. The other two could play a role, who knows? The other 2 properties we have is that the tans from the same point. So if we have 2 tangents from the same point, like for example, this, okay, imagine it touches the circle, then the tangents will be the same length. And then the other property we have with tangents is tan chord theorem. Maybe they ask you a question with like angle of inclination, that type of story. But we're not going to look at that today. The more likely thing that comes into play is the relationship between the tangent and the radius. Okay. Then another question they can ask you is the length of a tangent when you are not given one of the points. So for example, let's say there's your circle, whatever. You know what the center is, and you know what that point is. Then what you can do is, this is your radius. We know that the tangent and the radius are perpendicular. And then that, if you know this point and you know that point, then you can find this length, which is the hypotenuse. So then the thing that can come into play is Pythagoras. Let's look at an example. Okay, so here I just drew the sketch also. It is given here to you that that is the center of the circle, 0, 2. So this is just a circle that moved up 2 units. Then they tell you the radius is square root of 20. In other words, your radius square will be 20. Then AB is a tangent. Great. They're telling you this is a tangent at B. And then the coordinates of A is given to you. Okay. Are you already seeing how what we just discussed in the previous pages is coming into fruition or play or whatever? Yeah, our first question is asking us for the equation of the circle. Now, for an equation of a circle, we need the radius squared and we need the center. That's all. We can just substitute. So we take the opposite sign. Okay, it's not going to have an influence here. And then this will be -2. Our r squared will be 20. So in other words, our answer will be x squared plus y minus 2 being squared is equal to 20. In question 2, they are looking for the length here, AB. Now, as discussed on the previous page, we are not given B. Okay, then the next question they tell you B. You cannot use information they give you now in question 2. Okay, you're not a time traveler, so you're going to have to use the property that the radius and the tangent are perpendicular, and then you are going to have to use these 2 points to find this distance. We already know the radius is square root 20, so we have that, and then we're going to use old Pythagoras. Just remember, you can't assume perpendicular, you must prove it. So we're just going to quickly say that NB is perpendicular to BA, reason tan perpendicular to radius. Then we can go find the length of NA, just substitute into your distance formula. But it's actually nice to go find NA squared because that's what we're going to use for Pythagoras. Okay, so then you'll get NA squared as 100. We already know that NB squared is going to be 20 because NB is square root 20. And then Pythagoras says the hypotenuse squared is equal to the other 2 sides squared and added together. So AB will be the square root of NA squared was 100 minus NB squared is 20. So that will be square root 80, which is 4 square root 5. And then just remember to write Pythagoras as your reason. Okay, it goes next to the statement. Okay, you could have either started there or there, but Pythagoras needs to be there. And then we just add, we weren't given a unit, they just said units. Now in this last question, they are saying B is 4, 4. okay? And now they want you to find AB, okay? The equation of AB. AB is a straight line, so you need a gradient and you need a point. And we have both. We have 2 points, so we can find a gradient. So our gradient of AB is going to be your difference in y's over your difference in x's, which is -2, and that makes sense because it is a decreasing line. And then you can choose which formula you want to substitute in, whether it's y equal to mx plus c, and then just finding c and substituting back in, or if you want to do it in one swoop. I'm going to use the second one. It doesn't matter which point you substitute. I would substitute 4, because it's just easier. There's no minuses or whatever. Remember, this -2 is going to be multiplied with each term, so that would be a positive 8. And then if you want to bring this -4 over to the other side, you will do that by adding 4. So our answer is going to be y equal to -2x plus 12.